So here it is, Sami again, determine the derivative of y equals x to the power of sine x. The only way you could do this is you have to bring that sine x to the bottom. How do we bring this sine x to the bottom? We have to ln both sides. So we have to introduce the natural log to both sides. So it's going to be ln y equals, when you ln the right side, that allows you to bring the sine x down because that's part of the log rule. So it becomes sine x ln x. Now we got to take the derivative of this and with respect to x, but here we have a product rule right here. And the product rule is if y equals ab, a times b, then y prime would be a prime b plus b prime a. And therefore here we'll call a as sine x. And therefore a prime would be the derivative of sine is cos x. And b is ln x, and the derivative of b prime of ln x is just 1 over x. Now, we'll just fill all of that into here. So a prime, or we start right on the left. So the derivative of ln y is also 1 over y. But because you're taking the derivative with respect to x, you have to say dy dx, implicit differentiation, equals the derivative of sine x is cos x, as we said here, times ln x, the b, plus b prime, which is 1 over x, times a, which is sine x. Now what you need to do, you need to get rid of the y on the bottom here. So multiply both sides by y, or just cross multiply the y to the top there. So you'll have dy dx equals, if you cross multiply the y there, you get y brackets cos x ln x plus 1 over x sine x. And now what you do, the y is this right here. That's what the y equals. So instead of leaving it as y, you just rewrite it as dy dx equals the y, which is the x to the power of sine x, in brackets cos x ln x plus, and we'll just write this as sine x over x, because 1 over x times sine x will just give you that. And that's as simple as it is once you ln both sides. If you don't ln both sides, then this becomes very complicated. Thanks for watching. Till next time, bye-bye.